All right, welcome. Today we're going to do a quick, practical physics refresher. Look, if you move heavy things for a living, or you're the one managing the equipment that does, this is definitely for you.
So let's just jump right in with a question you probably face all the time. To really answer this, though, we've got to break down three core ideas that all play together: potential energy, kinetic energy, and work.
Okay, first up, let's think about that load before it even budges. It's just sitting there on the floor, right? Looks like it's doing nothing, but in the world of physics, it's actually packed with potential.
Yeah, we call this potential energy. It's not energy that's happening. It's stored energy. It's the capacity to do work, just coiled up, ready and waiting. Kind of like a stretched rubber band or a fully charged battery.
And here's why this matters to you on the job. A heavier load, or lifting it higher, that means you've got way more stored energy on your hands. And that's energy you have to control, not just going up, but coming down too.
So, okay, what happens the very second we start to lift that load? The moment we put it into motion? Well, that brings us to our next big idea.
The instant that thing starts to move, all that stored potential energy starts to transform. It becomes what we call kinetic energy. And it really is that simple. If it's moving, it has kinetic energy.
Now, this is where it gets really important for anyone on a job site. Kinetic energy isn't just about how heavy something is. It's also about how fast it's moving. And get this, the relationship with speed is squared. What does that mean? It means if you double the speed of a load, you don't double the energy, you quadruple it. That is a massive deal when you're trying to control something heavy.
And this, right here, just lays out the difference perfectly. Potential energy is all about where the load is, its position. Is it on the ground, or is it 10 feet up? Kinetic energy is about what it's doing. It's about motion. One is stored up and ready. The other is happening right here, right now.
So you might be asking, how do we actually get from potential to kinetic? What's the thing that makes that energy transfer happen? Well, that's where the concept of work comes in. Let's see how this ties everything together.
You know, in our everyday lives, work can mean a bunch of things. But in physics, it's super specific. You are only, and I mean only, doing work if the force you're applying actually makes something move. If you push against a brick wall with all your might and it doesn't budge, you haven't done any work in the physics sense. No movement, no work, period. And this just spells out the whole process, right? Work is the bridge. It's the action, the thing you do, that takes energy from one state and moves it to another. In our case, is taking that stored potential energy and turning it into the active energy of motion.
And here's a really neat detail that makes it all click. Since work is literally the act of transferring energy, it makes total sense that they're both measured in the exact same unit, the joule.
Okay, so now we're getting to the real heart of that question we started with. Because it's not just about doing the work, is it? On any job, what often matters most is how fast you can get it done. And this brings us to power. Power is all about the rate of that energy transfer. You know, for any tech who has to pick out a motor or a winch or really any piece of machinery, this is probably the single most important factor. It's the how quickly part of the whole puzzle.
So the standard unit we use for power is the watt. And its definition? It's actually beautiful in its simplicity, and it ties right back to everything we've just talked about.
Check this out. 1 watt is just the amount of power it takes to do 1 joule of work over a period of 1 second. See that? It directly links the amount of energy you're moving to the time you have to move it. Just take a look at this table. It makes it crystal clear. Lifting that load requires 1,000 joules of work, right? If you take 10 seconds to do it, you need 100 watts of power. But if you want to get it done in just 2 seconds, you need 500 watts. Same job, same amount of work, but you need 5 times the power to do it 5 times faster. This is exactly why a more powerful motor doesn't necessarily lift a heavier load. It lifts the same load, just a whole lot faster. All right, let's pull all these ideas together now with one final, really powerful principle that kind of governs everything we've just discussed. It's called the work-energy theorem, and it basically says this: the net work done on an object is equal to the change in its kinetic energy. And honestly, this is the ultimate practical takeaway. It means the total work you pump into a system directly and predictably changes its motion. So what does that actually mean for you? Well, it's a direct cause and effect thing. If you do positive work on the load, you're pushing it, lifting it, its kinetic energy goes up and it speeds up. But if things like friction or gravity are doing negative work, they're fighting you,
its kinetic energy goes down and it slows down. That net work is just the total of all the forces combined. The work you put in minus the work that's pushing back.
So the real bottom line is that this isn't just some abstract idea from a physics textbook. It's a predictive tool. If you can calculate the network, you can predict exactly how that object is going to behave. It's pretty powerful stuff. And that brings us full circle, right back to where we started. So the next time you're sizing up a job, what are you going to be thinking about? The total energy you need to move that load, or the power you need to move it in the time you've got? You know, understanding that difference, that's really what separates the good technicians from the great ones.